Here's another example of solving a nonlinear system. Exercise 3. Solve the system y equals 2x and x squared over 2 plus y squared equals 1. In this case, we have y equals 2x as an equation that's a line. And the second equation, x squared over 2 plus y squared equals 1, you should recognize this as an ellipse equation. So we're trying to find points where a line and ellipse intersect. We've seen a couple of examples where there have been two solutions so far, and certainly if you want to imagine an ellipse and a line, you can imagine an ellipse and a line intersecting at 2 points, but it's totally possible that the ellipse and the line could possibly have no intersection is possible. This was our 2 points situation. And it's also possible, you should be able to imagine, that a line and an ellipse could possibly intersect at just 1 point. And you don't need to know this ahead of time going into the problem. I think you need to know about the possibilities, but the algebra, the process, should guide you to the correct solution, whether there are 2 solutions, 2 points, whether no intersection is possible, meaning that's a no solution situation, or whether there's just one solution from 1 point of intersection. So let's go ahead and start working on this system. And notice that in equation 1, so y is already isolated in equation 1. So we can substitute into equation 2. Let's go ahead and do that. I'll take equation 2, x squared over 2 plus y squared equals 1. And I'm going to replace y with 2x. So it's the y that's going to get replaced in this substitution. Recopy x squared over 2 plus, that's 2x in parentheses squared equals 1. So this actually is x squared over 2 plus 4x squared, when I square the 2x, equals 1. And I'm ready to solve for x. I have an equation in one variable. Since I have this fraction over 2, I think I'm going to go ahead and multiply both sides of the equation by 2. So I'm going to take 2 times x squared over 2 plus 2 times 4x squared equals 2 times 1. I have to multiply each term by 2. The 2 will cancel on the first term, so I have x squared. And the 2 times 4x squared gives me 8x squared. X squared plus 8x squared equals 2. And I just want to maybe reiterate this, that we're multiplying both sides of this equation by 2. I can't just cancel 2 with the first denominator here, because this 2 that I'm multiplying by had to be distributed, and that's why I went right ahead and distributed it in that step that when I was working through the steps in blue. And now I can combine like terms. X squared plus 8x squared is 9x squared equals 2. And I have a quadratic in x that I want to solve with just an x squared term, no x term. So the square root method is going to apply. But before I take square roots, I want to isolate x squared. And so I'll have x squared is equal to 2 divided by 9, right? I had to divide both sides by 9. And now I can take square roots. X is equal to plus or minus the square root of 2/9. I can write those square roots separate. Square root of 2 over square root of 9 is 3. And I have my two x values, right? X is equal to positive square root of 2 over 3, or x is equal to negative square root of 2 over 3. And now I have to find y, find the corresponding y values. And here it's real nice because I can just plug into y equals 2x. So y equals 2 times square root of 2 over 3, or 2 square root of 2 over 3. And if x is negative square root of 2 over 3, y equals 2x gives me y equals 2 times negative square root of 2 over 3, or negative 2 square root of 2 over 3. And so here's another situation where we have two solutions. So I guess I'm in some sort of situation like this, right? We know now because we got two solutions, where my one point is square root of 2 over 3, 2 square root of 2 over 3. And my other solution is negative square root of 2 over 3, negative 2 square root of 2 over 3. And there we got it. We got it. This one solve for. Camera out a bit. This actually was a pretty straightforward problem. There we go. All right, so I'd like to go right on to another problem in this same video segment. So let's take exercise number 4. And what we're going to see here is a slightly different situation than what we've seen so far. Because just notice, first let's look at the equations that we have. Solve the system. X squared plus y squared equals 9. 3x squared plus 2y squared equals 20. And now that first equation is the equation of a circle. The second equation you should recognize as the equation of an ellipse. Now, it might not be so obvious that that's the equation of an ellipse because we don't have the 1 on the right-hand side. But if we divided both sides of this equation by 20, we could convert that to standard form. In fact, so we got a circle and an ellipse, and we're trying to find the points of intersection. We could possibly have as many as, if we have a circle and an ellipse, we could possibly have as many as 4 points of intersection, right? Like we could have something kind of like that. So possibly 4 solutions to this system. And what's a little bit different here is, notice that we have no x or y terms, we just have x squareds and y squareds. And I have an x squared and a y squared term on the left-hand side of both equations. I can use what's sometimes called the addition method to solve this system. If we call this equation 1 and equation 2, I can take equation 1, and what I'm going to do is I'm going to multiply equation 1 by a constant so that I can add these two equations together and get one of the variables to drop out. So I can do this because of the way the terms line up and because I just have x squared and y squared terms on the left, constant terms on the right. So for instance, if I wanted the x squareds to drop out, I might multiply equation 1 by -3. So what I'm going to do is I'm going to take that x squared plus y squared equals 9. And I'm going to multiply both sides by negative 3. Of course, I got to distribute through the sum on the left. So I'll have negative 3x squared minus 3y squared equals negative 27. And then what I can do is I can add equation 2. So I have negative 3x squared minus 3y squared equals negative 27. I'm just going to add 3x squared plus 2y squared equals 20. And when I add on the left-hand side, negative 3x squared plus 3x squared is 0. Negative 3y squared plus 2y squared, that's a negative y squared, equals negative 27 plus 20 is a negative 7. So I was able to get the x squareds to drop out using this kind of special addition technique. I would not call this substitution. And now I have an equation in y that I can solve for. Solve for y. I would multiply both sides by negative 1 to get y squared equals positive 7, because I had a negative on both sides back there. And so when I take square roots, y is plus or minus the square root of 7. And I got my y. Solve for y is square root of 7, or y is negative square root of 7. Now I have to find the corresponding x values. And I have to go back to one of my original equations to find x. So solve for the corresponding x values. Now here I don't have an equation where x is solved for. And I think the simplest one to choose is just x squared plus y squared equals 9. That's what I'm going to plug into. So I'm going to take my square root of 7, plug it into this other equation. I get x squared plus square root of 7 squared equals 9. Or x squared plus, that's just 7. The square root of 7 squared is 7 with no square root sign involved. So x squared plus 7 equals 9. Subtract 7, so x squared is 2. X is plus or minus the square root of 2. So I get two solutions here now, because I started out with y being the square root of 7. And we're saying in that case, x could be either the positive square root of 2 or the negative square root of 2. And now that was only my analysis of the positive square root of 7 for y. We also have the negative square root of 7 for y. That also has to be plugged in to one of these equations in x and y. So I'll use x squared plus y squared equals 9. And let's see, x squared plus negative square root of 7 squared equals 9. And I got to find the corresponding values of x for that y value. Now I have x squared plus, here I'm squaring a negative. A negative times a negative is positive. So negative square root of 7 times negative square root of 7 is going to be just plus 7 again, equals 9. So a negative number squared is positive. The square root of 7 squared is 7. X squared plus 7 equals 9. X squared equals 2. X equals plus or minus the square root of 2. My x values come out exactly the same here as they did when I plugged in positive square root of 7 for y. But this corresponds to different solutions now. It's a positive square root of 2, negative square root of 2 for x, but these both corresponded to negative square root of 7 for y. Okay, so we have 1, 2, 3, 4 solutions. solutions, 4 points of intersection. And that shouldn't seem that unusual. Like we said right at the very beginning, a circle and an ellipse could cross in a way where they cross at 4 separate points. And that's exactly what's going on here. I'm going to pull the camera out again. And there's our whole problem. And